Hello, everyone. Good afternoon. Dear authors and invited guests, welcome to Technical Session 1G. Myself, Richa Shah, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you to the Ninth International Congress of Information and Communication Technology, ICICT 2024, London, UK. The ninth, the ninth edition of the conference is being organized in a hybrid mode. The physical event was organized in London, UK on the 19th and 20th February 2024. And the virtual event is being held through Zoom today and tomorrow, that is the 21st and 22nd of February 2024. I hope you will enjoy the knowledgeable and interactive session throughout the day. In the session, we have six presentations. Each presenter will be given 12 minutes each for the presentation and 2 minutes for question and answers. On 10 minutes, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Just before we get started, I would like to introduce you to all the chairs of this session. Um, Rachna Patil, Associate Professor, Vishwakarma Institute of Information Technology. Dr. Ratna Nitin Patil has around 25 years of teaching experience at various universities and engineering colleges pan-India. He is currently an Associate Professor in Artificial Intelligence and Data Science Department at Vishwakarma Institute of Technology, Pune, Maharashtra, India. Her area of interest includes natural language processing, machine learning, artificial intelligence, and meta-heuristic algorithms. She has published more than 20 research papers in international journals and conferences. She has filed around 11 patents in the field of AI and IoT. Dr. Reina Alfred, Associate Professor at University of Malaysia, Sabah, Malaysia. Tanner Alfred is an Associate Professor of Computer Science at the Faculty of Computing and Informatics, University of Malaysia, Sabah in Malaysia. He leads the Advanced Machine Intelligence AMI research groups in UMS, and he has led several projects related to knowledge discovery and machine learning in big data. Now I would a quick welcome to the session chairs. Now I would like to start with the papers. Um, I would like to call upon Mr. Richard Apau to share their paper titled A Secure and High Embedding Capacity Image Steganography Scheme Using Image Enhancement Technique, Compression, and Genetic Algorithm.
Okay, thank you. I'm sharing my screen.
I'm sorry?
Yeah, I cannot share whilst you are sharing your screen for me
You cannot share your screen?
because you are already sharing the screen. So you have to stop
Yeah,
sharing.
I'll stop the presentation. Give me a second. Yeah. See if you can share it now.
No, because I'm still seeing your screen there. Okay. Okay, good morning. I hope you can see my screen.
Yeah, it is visible.
Okay. Thank you very much. My name is Richard Apple, and I'm making a presentation on behalf of the authors. Our paper is a secure and high embodied capacity image steganography using image enhancement techniques, compressions, and then genetic algorithm. I am at the Department of Science and Technology in Ghana. So this is the outline of my presentation. I'll do a bit of introduction, the problem underpinning the study, the main objective why we did this study, the methodology we used, the results that we obtained from the experiment, and then a conclusion and suggestion for future research. The work is basically based on a combination of steganography and then cryptography. You must have known that due to increasing cyber attacks, data have become targeted by cyber criminals. And once we recognize that data is currently the most important asset to organizations, then it is important to constantly improve how data is communicated in order to ensure the security and privacy of data. And so within the data communication environment, steganography and cryptography have become very important. Here we mean when we talk about steg, we are talking about hiding the existence of the message whilst the message is being transmitted so that people wouldn't see that there's a message in whichever communication we are doing. Cryptography, on the other hand, actually scrambles the content of the message so that even if a person sees it, the person is not able to know what message is being communicated. And so in data communication, the two concepts have been brought together to ensure that the data is secure and it is robust against statistical analysis. Now, purpose of steganography is to achieve three basic aims. One, to ensure that a large amount of data is communicated or sent at a time, and that data that is sent is how the security is protected, and then it is also robust against any attack that it may be experienced. But we have noticed that while steganography is trying to achieve this aim, there was a concept we call stagger analysis, which is actually the counterproductive to steganography. So what stagger analysis does is just to ensure that the message that has been hidden is now actually detected using various statistical techniques. There are so many types of steganography in existence, but image steganography has become the most preferred due to the quality of images and some redundancies that images have. So what is actually the problem statement? We have noticed that, yes, several image steganography techniques have been proposed, which is aimed at ensuring security. But of course, we have noticed that a lot of the existence of the application either ensure security and then not large amount of data to be able to pass through the application. So we decided that, okay, there was a need to balance the security and then the payload capacity. Payload capacity here means that the amount of data that can be hidden within the system that had been developed so that you send it. It is good for purposes of bandwidth consumption. It's also good for the security, and then it is also good for robustness of the data that is being. Overall, the aim of data communication to ensure that one, the data achieves confidentiality, it achieves integrity, and then the data is available when it is required. So that is the CIA triad of security of data. So our main objective of this paper was to come out with a method that is actually capable of maintaining security whilst also achieving robustness and security. What did we do? The target was to ensure that within the pixels of the image that we have selected to hide it, the best place is actually located using what we call the best fitted chromosome, which is a feature that we implemented through the genetic algorithm. One method, one method did we actually put in place. This study combines three techniques. One, we have image enhancement techniques, we have compression, we have cryptography, and then we have genetic algorithm. The compression, we use arithmetic coding to ensure that the data that we want to send is first of all compressed. And arithmetic coding is a lossless compression algorithm. So it reduces the size of the image for us to enable us to hide as many amounts of data that is applicable within the system without distorting the image quality. Here we are talking about the cover image. That is the image where we are going to add the data. So genetic algorithm is first applied on the secret data we want to hide. Now, when the compression is done, then we move to the second step of our application, which is about doing encryption. So here, cryptographic application is used, and what we use there is the little pair cryptography. We told the little pair cryptography over other cryptographic protocols due to the security, its small size of the key size, and why it ensures security. Then, in terms of hiding the data within the image, we decided to apply what we call the genetic algorithm. This is a concept in biology that has been applied in computer science. So genetic algorithm is basically about natural selection. So there are so many parts of pixels. So within the pixel, what the genetic algorithm does is that it selects the best pixel location where the data has to be hidden. So that when the message is sent, it becomes difficult for the cyber criminal to detect where within the pixels of the image that data is hidden. Now, so there was a calculation we do to know that, okay, the pixel where the image is been hidden is good. We calculate what we call the best fitted chromosome. And that one is calculated using PSNR, what we call the peak signal to noise ratio. There is a threshold. The literature is saying that if your P signal to noise ratio is about 30 dB, that's 30 decibel, then it is assumed that the quality of the image is good. So we decided to implement that threshold. Where we insert and we calculate the best filter chromosome, and it is less than 10, then we apply the retinase-based image enhancement technique to improve the quality of the visual image. So that is the method. So this diagram actually shows the flow chart of all the processes that we went through, from the compression to the encryption, that is the cryptography, to the genetic algorithm. The genetic algorithm, we go through three processes of the genetic algorithm. That is the mutation, the reproduction, and then the crossover. Now, the experimental results, we decided to use three pictures or three images from a well-known database. I mean, one of the databases is the Signal Processing Institute of the University of California. It's called the CP. We downloaded the images from there. And then we also have the uncompressed image color. That's the UCID. It's also a database that has a lot of images that is used for experiment. So we obtained these images from there. Now, each of the images, you can see that there was some histogram. Those histograms actually shows the comparison of the cover image when the data was not hidden. And then the run by the right side is actually the image, the histogram of the image when the data is hidden. So some of the image, you can see that the changes in the histogram is not visible for you to see. Even though there are changes, you might not see that there are changes. That actually demonstrates the quality of the system. And so we decided to do the experimental results. And here in the experimental results, what parameters did we use? We used the payload capacity in terms of bits. We also actually also use bit rates. And then we also use the peak signal to noise ratio. And then we decided to compare our applications with three previously well-known applications that existed using actually the same methods. And so our proposed method is compared by ITAR, which was developed last year, and then we have Super, which was developed in 2018, then Hussein also proposed a similar. So we decided to compare our application with their findings using the various three images, because in their system, they also use three images. And in all, you could notice that in terms of the bit rate, we were able to achieve 4.27 bit rate because that is actually our aim of ensuring that there was a higher amount of the data that is hidden. But while that higher data is being hidden, it should not distort the security. And then averagely, we were also able to have about 50.1 citizens. Of course, there
So
are some,
just a gentle reminder that 10 minutes are over and you'll have to wrap up in 2 minutes.
yes, I'm finishing soon. Don't worry. So our system achieves 50.1 citizens. So in terms of the graph, this is how the graph looks like in terms of the existing methods and then our system. Of course, there are some um, methods that perform better in terms of the performance, in terms of the security. In conclusion, By applying the arithmetic coding algorithm, our system was able to increase the embedding rate by 26% as compared to some of the existing methods. We were able to actually achieve 50.16 decibel as the embedding rate. Of course, the average embedding rate that is acceptable is 30.0. And then we also have to be able to achieve 4.27 bits per pixel, which is also quite high, even though there are others that have achieved 5 and 6 and all that. But what we notice among them is that whilst we are achieving higher bit rate, the security of the system is coming down. We also decided to do the discrete entropy, the standard deviation, and then the similar structural similar index to actually know the distortion to the original image and then the stability. In the future, we are thinking that artificial neural networks, ANN, or even blockchain technologies would be applied to ensure that security is improved. Emerging technology. So that is currently being implemented. And I think that blockchain and artificial intelligence will help in this regard. Thank you.
Mr. Richard, I have one question based on your topic, what you have presented. What ways does the use of genetic algorithms contribute to the overall security of the steganography process?
Okay. So what the genetic algorithm does is, you see, in genetic algorithm is like I mentioned, it goes through the biological process of natural selection. And so here in the population, we are looking at the individual with the strongest feature to reproduce the next individuals. So with respect to this security, there are pixels. And so places within the image pixels have to hide data. So what a genetic algorithm does, it selects the best pixel, which is the have the highest value in terms of the peak signal to noise ratio, so that the data, because of course the data is also converted to binary. So in that pixel, we just change. So for example, if it is a bit of 0, because the data is coming, that bit could now change to bit of 1. But because the overall image is such that changing of that bit will not necessarily alter the look and feel of the image, which we call the human visual system. So that when you see, you wouldn't do that. So what a genetic algorithm does is it selects the best fitted chromosome. And here, in the application of steganography, here it is selecting the best pixel location where the secret data has to be hidden.
Okay, fine, fine.
Thank you.
Thank you, Mr. Richard.
Thank you.
So I would like to now call Ermira Mukhtar for the next paper titled A Systematic Literature Review on Virtual Reality for Hearing Impaired. So, ma'am, are you there in the meet?
Miss Shafika, are you there in the meeting? I think, Richa, we can go ahead with the next paper.
Yes, ma'am, yeah. Give me a second. So now I'd like to call upon Kue Uraima for the paper titled Analyzing Handwritten Log Data for Evaluating Computational Thinking, Investigating State Transitions in Drawing Tasks Using Pen-Based Tablets. So you may please present.
Hello. Hi. I couldn't share my slide just now.
Yeah, give me a second. I'll just stop
Okay.
sharing.
Okay.
Yes, you can present now.
Okay. Okay. Can you see my slide now?
Yes, so just for clarification, Armia is presenting her presentation, and next we'll be calling upon Kohai.
Okay. So, hello everyone, to the chair and all. Today I would like to present my papers entitled Systematic Literature Review, Virtual Reality for Hearing Impact. Before that, my name is Amira Shafika Beti Mokhtar, and this is the content of my presentations today. First, I will start with introduction, go to methodology, results and discussion, limitation, future works recommendations, and I will end with conclusions. So with a hasty state, this is the introduction to my presentation today. Basically, this paper is about the virtual reality. So virtual reality or VR is a wearable technology that immerses the user in a virtual environment, especially to meet the growing demand for visual communication channels. Besides, VR or virtual reality is also a part of assistive technology devices. So, assistive technology devices are very common to improve the skills of people with disabilities, such as hearing impaired and other type of disabilities. However, this paper choose to scope the study to the hearing impaired individuals for them to interact with the real world through the VR devices. Then, this paper also highlights the needs of design principles such as empathic, visual interaction, and assistive technology. So, empathic design principles are a user-centered design UCD approach that considers the user's needs and feelings for the product developed. Besides, visual interaction design principle also crucial when developing the assistive technology for the hear impact people because these visual interaction design principles are focusing on the interface design when designing a product to help the users achieve their needs and goals. So, in order to identify the needs of VR models and design principles that are suitable for hearing impaired individuals, a systematic literature review is needed and has been conducted. So, this SLR adopted the Prisma method. So next, I will discuss on the methodology. First, I'll start with formulating research questions and objective. So this is the research question and research objective for this SLR. First, the research question is what are the VR models that currently are available? So for here impact. So this paper aims to identify the existing models of VR for hearing impact. Then, second research question, what are the design principles used to design the current VR for hearing impaired? So this paper also highlights the design principle used for existing VR model for hearing impaired. Next is to determine the resources. So two databases were chosen. As these two databases are very popular and well known for the eligibility for computer science field. So this is the string and keyword used for both databases, and this is the result in return. For Scopus, there are 2,357, and for Web of Science, 97 results in return. Okay, then I determine the inclusion and exclusion criteria. For the inclusion criteria, as I mentioned earlier, this research are scoping for hearing impact populations, and the document type chosen for this SLR is journal and conference, as I require the paper with results. Next is the timeline. I make the range of 2021 until the latest is 2023 papers. This is because the evolution of technology uh, very fast, very fast. So we need to get the latest technology to be adopted in this SLR. As for the language, I choose the paper with English language only to avoid the needs for translation. So as for the exclusion criteria, I exclude the other disabilities and the document type other than the journals and conference. Also for the timeline, the articles that was published later than 2021 and the language that other than English. So as for the last methodology is the data abstraction and analysis. So basically, the records that have been identified from Web of Science is 97, and from Scopus there are 2,357. So total papers that were screened is 2,454. However, due to the exclusion and inclusion criteria, the last result I got is 222 to be screened with the full text articles. Then I exclude 12 from the Web of Science and 193 from Scopus due to the duplication of articles. We are for mentioned for multiple disabilities, not just for the hearing impaired and not mention the VR. So at last, I got only 5 papers for to be included in the SLR result. Next, this is the existing VR model that I found between 2021 until 2023. So there are 4 existing VR models that currently available, and most of the models are the immersive types of VR, okay, which require the HMD head mounted devices. So the design principle used, most of the existing VR model choose to adopt the user experience design. Okay, and besides that, the VR models number two, choose to adopt both user experience and assistive technology. Okay, which is good because this is the VR models that was designed for sign language learning. Okay, then as for the VR model number three, it only adopt the visual interaction. Okay, so it highlights the visual interaction since it is the training simulation. Okay, next is the design principles. So as you can see here, these are 4 design principles that were highlighted by the existing researcher, which is the user experience design. And most of the researcher choose to adopt these design principles. Okay, since the feedback from the users are very important when we are developing the technology for the people with disabilities, particularly the hearing impact, for us to know that the technology developed are useful for them. Okay, then second design principles that were highlighted by some of the researcher is assistive technology. Okay, then only one researcher adopt the empathic design principles, and for the visual interaction design, 2 studies adopted the visual interaction design. Okay, so as for this paper, 4 design principles were highlighted. First is user experience. User experience is a principle used to design the product, system, environment, by including the users to experience themselves by using the product developed. And the second one is the assistive technology. It is as any product, instrument, equipment, or technology that was designed for people with disabilities. So it called as assistive technology. And next is the empathic. So empathy is basically a user-centered design methodology that considers the user's emotional connection to a product and its objective to ascertain the needs of customers. Okay, particularly the users lah. Okay, then visual interaction. So the last design principles to highlight is visual interaction. This is the principle that focus on the interface design of the specific product, and the interaction design influence the interaction between the users and the product or systems. Okay, so as for the limitation and future works recommendation, the limitation of these papers or SLR process is the dearth of literature related to the development of VR technology for hearing impact individuals. Most VR were designed for other type of disabilities such as visually impaired. Okay, so lacking, there's lacks of research made for hearing impact in developing the VR technology. Then, second limitation is the limited access to the articles related to the VR development for the hearing impact. And lastly is the irrelevant articles discovered during the SLR. Most of the articles found are not relevant to the VR itself. Most of them are developed for the hearing impact with mixed reality or augmented reality. So as for the future work date recommendation, I could recommend that future researchers could consider other type of database since I'm using only two database, which is Corpus and Web of Science. And
Ma'am, like I would just like to
okay,
remind you that 10 minutes are over. You
okay,
could
okay.
continue, or you could just wrap it up.
All right. So the future researcher also can consider the other design principle to highlight, other than four design principle that I found during the SLR process. And future developers also could enhance the SLR by referring to this paper. So to conclude, this SLR process lists the existing VR models along with the design principle adopted by researchers, and the finding of the SLR can be used as a guideline for the future developers or researcher for when they are designing or developing the VR models for hearing impaired individuals in future. So that's all from me. Thank you.
Yeah, I have a question. Um,
Yeah.
because in the methodology you mentioned about all those things, but you didn't mention about the keyword that you use to find all the papers. What keyword do you use?
The keyword is here. Virtual reality, and I use synonym for hearing impact, which is hearing impairment, hearing disability, or deaf, but not the augmented and mixed reality. I use the same keywords and strings for Scopus and Web of Science.
And based on the um, filtering, you only get 4 papers.
Yeah. No, I get 2,000 357 for Scopus and 97 for Web of Science. But after doing the after excluded due to the inclusion and exclusion criteria and manually discard, so I found the one that really meet the needs of this paper or SLR process is only five, the latest one.
Yeah, but how do you verify that your filtering process is valid? Because
Valid.
based on 4 papers only, you cannot do review. How?
Okay,
What
so
is the minimum number of papers that you require to review certain areas? Have you looked into that?
Actually, there is no minimum or maximum number of papers as long as the one that the criteria that I've mentioned is meet with my SLR objective. So I think that one is good enough for my SLR outcome.
Normally, this one related to sampling because based on 4 papers only, you cannot generalize the topic. Okay, so
Mm-hmm.
that's my concern. I never
Okay.
got a review paper based on 4 reference only. Very very limited. But
Mm-hmm.
have you gone through other review paper? Because if I Google now, there are a lot of visual reality work on
Uh,
hearing impairment. So how yours is different from them? What is so unique
okay.
about yours?
Okay. Because the existing papers related to VR for here impact, they are only mentioning the application and the development of development process of the VR. They are not mentioned what are the design principles or element used when they are developing the VR for the hearing impact. So my SNR objective is I want to know the design principles that are being used when they are developing the VR models for hearing impact. So most of the papers that I found they only mention the process of developing the VR for the hearing impact. They are not mentioning the design principles. So that's why I found from the inclusion and exclusion criteria, also with the manually process, I only found 5 articles that are really mentioning the design principles that are adopted when they are designing the VR for hearing impact. Because I'm not focusing on the VR application. I'm focusing on the design principles that being used in developing the VR models for here impact.
So there must be a reason why you study this, right?
Yes.
Why this is so important? Does it have any impact, or can you support by any reference that the design will affect out?
Hmm. Okay. The design principles is very crucial and important for the future developers or researchers to refer when they are when they want to design and develop the VR application for the hearing impact to ensure that
Yeah,
the
yeah.
VR
We, we,
developed are really
we
useful
understand
for
that
them.
one, but that one is
Yeah.
based on textbook. It's better to
Yeah.
support them based on journal paper, not based on
Okay. Okay.
general knowledge.
Okay.
So we need to get support from journal paper that they have done study on this one and conclude that
Mm,
the design has impact on output or objective of the project. Okay, that's
okay.
all
Okay.
from me.
Thank you. Okay. Thank you for your suggestion.
So now I'd like to call upon Kohei Urayama for the paper titled Analyzing Handwriting, Log Data for Evaluating Computational Thinking, Investigating State Transitions in Drawing Tasks Using Pen-Based Tablets. So please could you share your screen and start your presentation?
Yes,
I'll pause
okay.
my sharing.
Can see my presentation. Is it okay? Can see my presentation slide.
Yes, sir, it is visible.
Okay.
I can see it.
Okay. My, my name is Kohei Urayama. I will presentation my study. Title is Analyzing Handwriting Log Data for Evaluating Computational Thinking. And first, I explain the aims of study. One of the correct problem is that computational thinking skills are untrainable without the use of a PC. Therefore, it is difficult to teach computational thinking skills in primary education. In addition, it is impossible to deal with students who do not know how to programming. Our proposal is to provide a learning environment in which computational thinking skills can be estimated from tablets and handwritten logs. As a method, subjects are given tasks that do not require programming, and uh, features are found that identify uh, whether the subject is tackling the task perceptively. As a social contribution, maybe we can provide a learning environment in which competition thinking can be trained. This section describes the research background. Currently, it started in references that computational thinking skills need to be addressed in education. So there is a problem that it is impossible to deal with students who don't know programming. Therefore, I focused on experiments of methods to measure learning effort and translations using tablets and electric pen. Sorry, I forgot to translate. Um, Therefore, I propose methods for measuring computational thinking skills using tablet and electric pen. Sorry for translate in English. Uh, Computational thinking skills are explained. This is a theory proposed by Wim. Uh, can identify problems and analyze issues, and generate ideas for solving problems. Acquire the ability to think and express ideas in order to realize them, and can resolve, resolve and collaborate with others to get things done. And this is demonstrated when designing systems. This is the way of thinking when solving problems encounter, encountered when designing. Okay. So, uh, this section describes the problems when teaching current computational thinking skills. Computational thinking skills have been introduced as a national curriculum in many countries. However, they require the use of computers and purchase of equipment is expensive. In addition, as it is not using programming, there is a shortage of teachers who can teach programming. In addition, the definition and assessment of psychological variables. Psychological variable is still in its infancy. In order to make progress in this area, methods need to detect computationally competent students even before they have learned coding. Therefore, need mechanisms to assess computational thinking skills without knowing this study uses a tablet and electric pens as the measuring method. Previous research on estimation studies using tablets and electric pens is described. Currently, pen-based tablets are a popular method of learning. This is because they are as effective as traditional paper and pencil learning methods. There is also research on estimating learning behavior based on psychological evaluation. Translation and support requiring states are detected from handwriting logs. There, there are also studies that estimate confidence from handwriting logs. Confidence is important in learning. Given these studies, believe that the level of computational thinking skills could be estimated from handwriting logs and the size for estimating it. And so I focus on the Apple Illustrator working environment. Illustrator uses the layer function to draw illustrations. Layers are transparent virtual sheets that are used for layering. Layers are used for layer by layer drawing, like drawing and color. Each layer has a specific rule that layers change according to the order of the idea was it could be used to check whether the uh, pers- perspective is beyond false. But I explained the use of layers in this study. Build an experimental environment that forces subject to work in layers. If they tackle the tasks with foresight, they will finish the task without going back to the previous layer. If they tackle the task without foresight, they will go back to the previous layer and work on it, making correction as they go. And the hypothesis on this study. My hypothesis is that it might be possible to infer whether a prospect is making changes based on the complexity of changes. Subjects are given an illustration task. Subjects are asked to change layers in the following order: drawing, line, drawing, and so on. Measure the timing of the layer changes and analyzing the frequency of layer changes and handwriting logs to expect valid features. An experimental description I explained. Subjects are given a 20 minutes writing task. Writing logs is obtained during the experiment. And writing log is information obtained from the electric pen with writing pressure, altitude, annotation, and obtained. This log is machine learned as a feature, and the sensor used an iPad and Apple Pencil. This data is measured every 0.1 seconds.
So,
And
just a gentle reminder that 10 minutes are over. You'll have to wrap up within the next two.
okay, this is my second plan. And this experiment was conducted with 20 students at mesh of car on the right copy. Time, uh, time allocation was as follows. Experiment could be extended so that the subject were not rushed. This is environment experiment environment developed. And this is a recording being experimented with. First, uh, composition, drawing, and screen drawing. And this is screen drawing. Seven layers were prepared for environment. And in addition, there were three other types for each part of the car. This was done to facilitate the translation of layers to be subject. And The processing was carried out before analysis by machine learning, but the subjects are classified into two groups. Um, and this is a group that try to demonstrate. And this group is group that are able to demonstrate. And this group, that return was the group that failed to demonstrate. And and machine learning. A hidden Markov model was used. Three states were classified. And no prospect state is a state in which nothing is in prospect. Incomplete state is a state in which prospects are being developed. The complete state is a state in which there is a prospect. Hmm. Two groups difference. Look at the abroad. The figure below shows the radiation space area. Subjects who develop a drawing but return to drawing as unsaturated layer translation. Therefore, it is just possible to group subject according to the state of translation. Two group, this group, the group that we are able to demonstrate computational thinking skills and those that were not have different translation properties. The group that was able to demonstrate it had a higher quality of translating. Therefore, this grouping is assured to be correct. This is the table of lighting characteristics for the two groups. Each of the lighting features the output angle is increases as the process progresses for both groups. In addition, the group with higher computational thinking ability has a higher and writing process, pressure and speed are writing pressure increases with each uh, successive step and it is this decreases with
Sir,
each
could you please wrap up?
yes, uh, this is my composition. This is my conclusion. Yes. Okay, thank you for listening.
Okay. Mr. Kohe, Mr. Kohe, nice presentation. I have one question. Are there any specific patterns or sequences of state transitions that correlate with different aspects of computational thinking?
Uh,
Mr. Kohe, did you
yes,
get my question?
yes, two groups difference. Yes, um, I expand this table, that table. Um, for example, pressure is the uh, higher, higher and increases. So pressure is important features for thinking skills. And uh, low and high, that means two groups. These groups that try to demonstrate is low and light light groups that this group is high. I wrote this table.
Okay, I have one more question. You have implemented HMM model for analyzing handwritten log data for evaluating computational thinking. Am I right? Why didn't you go for other techniques like Viterbi algorithms and all so that you could have done comparison with other methods also?
Yes, I take timing logs by zero point 0.1 seconds. So 0 0.1 seconds didn't change anymore. Handwriting logs. Uh, so for example, random forest. That is, and that's on clustering and clustering is not current scores. The log doesn't change a bit. So I challenge the hidden Markov model.
Okay, fine.
Yeah. Mr. Kohei,
Yes,
this is time series, yeah, right? Time series analysis.
time series analysis.
Why you measure low and high and not looking at the pattern? I think that's what Dr. Ratna questioning you, the sequence of the pattern.
Sequence.
Like for this
Uh,
is the sequence, right? No, no,
this is yes.
no, 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 because your data can be considered as time series, right?
Can be considered
Time
time.
series, because you are taking the data like every 1 second or every 2 seconds. So this is considered as time series, right?
Yes, yes, at 0.1 seconds.
Time series, right? But you are concluding using low and high. So that's you have lost a few information like the sequence, the pattern, like from time A to B, what are the pattern going down or going up, right? So I think it's better to capture a sequence picture rather than low and
Uh-huh.
right.
Yeah, yeah, yeah.
Last question. Last question. The graph. Can you show the graph? The graph. Oh,
Oh, sorry. Ôi, ôi, ôi. Ôi.
Sir, are you presenting?
it's okay.
Sorry.
Yeah. Your work quite interesting, but you did not apply all the possibility to analyze your data. You did not capture the sequence. You only get the value for 1 point only, and also you said you are using clustering, more or less like that method. So basically, you can use sequential analysis much better. Okay, it's okay. So
Yes,
so
okay, thank you.
good effort. The next one.
Okay, so the next presentation is by Sanjay Rajal, and his paper title is Comparing Depth Estimation of Azure Kinetic and RealSense T435i cameras. So, Sanjay, you can start.
Thank you. Can you see my screen?
Yeah, but you have to make it okay.
Uh, First of all, I would like to thank the ICICT 2024 team for providing this opportunity to present our work at the STEM conference. It is an honor to present my team and bring forth our research work on comparing depth estimation of Azure Kinect and real sensitive 435i cameras. I am Sanjay Rizal and I will be presenting on this topic on behalf of my team. We'd also like to express our gratitude towards Ikebana Solutions Private Limited, Lalitpur, Nepal, for supporting this research with all the necessary hardwares, including the cameras. These are the outlines of our presentation. I would like to begin with the introduction part. In the field of 3D computer vision, depth cameras have become crucial for their applications in evolving fields like 3D reconstruction, simultaneous localization and mapping, object recognition, and human-computer interaction. Thus, research on depth estimation approaches, their influencing factors, and optimal operating conditions is important. Besides the depth estimation technology, the estimated depth also depends on various internal and external influencing factors such as sensors, warm-up time, distance from the target, target's motion, color, texture, and ambient lighting and temperature conditions. Studying such factors also simplifies the selection of cameras and capturing conditions. In our work, we have compared two widely used depth cameras, which are Azure Kinect here and RealSense. Azure Kinect is based on time of flight technology, which computes depth based on the time taken by the IR signal to reach the target and reflect back to the sensor. Oh, and this is the depth map generated by Azure Kinect. And RealSense, on the other hand, is based on stereo vision, which computes depth based on the disparity between two images taken from two viewpoints. And this is the depth map generated by RealSense. Throughout the experiment, we have tried to make the setup consistent. To ensure the consistency of data, we maintain the vertical and horizontal planes are consistent and place them on a base with 3D printed gyroscope. And hardware interfacing was done in NVIDIA's Jetson Nano. We also maintained a maximum overlap between the field of view of cameras to ensure consistency in the capture scene. Frame rates were kept at 30 fps for both cameras. And for ground truth measurement, we used Johnson laser 46001. And as per the RealSense D435i datasheet, the camera's depth start point, which we have represented here by ZS, uh, begins from the front glass cover uh, by 4.2 mm behind. And to compensate this, we have used these equations. And also the K4A depth, the camera is tilted 6 degree uh, from the color camera. And to compensate this, we have used open 3D's depth RGB transformation, which basically aligns the depth and RGB camera coordinate systems. And our experiment starts with the effect of warm-up on depth estimation. Before we start capturing the data, the sensors, which in case of K4 is a flight sense TM time of flight sensor, and in case of RealSense is vision processor D4. They need to reach their optimal operating temperature, and this time is known as warm up time. And from these figures, we can see after the warm up, there is significant reduction in the noises Okay, moving on to our next experiment, which is the influence of camera distance. Our target surface was a particle plane surface, and we captured the data at 0 0.5, 1, 1.5, 2, and 2.5 meters. And we used per pixel mean distance, random error, and systematic error as metrics for the comparison. And as we can see here, uh, the per pixel mean for K4A is very close to the ground truth. Even we move away from the even if we move away from the target, and while in case of real sense, we can see as we move farther from the uh, target, uh, the of distance from the ground truth deviates, and these results are further supported by the per pixel noise and offset from the ground distance distributions. And here, these pixels with zero standard deviations are actually the noises that introduced in the capture process. When experimenting with checkerboard as target, we found a checkerboard pattern in K4A depth data as seen here, which is not seen in the real sense uh, data. And further in investigating, we experimented this effect with this color palette, which is painted with acrylic paints. We have tried to incorporate all the colors of variable emissivity, and as shown in the table here, uh, the higher the depth, higher the emissivity, the higher the depth is. And the theory behind this is the absorption of IR light from TOF sensor by a surface with specific emissivity. Since the black color has the highest emissivity, IR was absorbed more by the black surface, leading to a longer return time of the IR light, and thus the highest estimated distance here. However, in case of real sense, no such effect was seen, as it it is based on the disparity between stereo images and not on the reflection of light. And our next experiments are influence of ambience, particularly illumination and temperature. To study the influence of scene illumination, we captured in two different settings. The first one is control setting, which is which we captured in indoor setting with control lighting conditions with artificial lights, and another one is uncontrolled setting, which we captured in outdoor with directional light. And as shown in these figures, uh, there is significant increase in noises as we shift from controlled environment to uncontrolled environment, both in case of real sense and azure. We already studied the influence of sensor temperature with our warm-up experiment, but this one is different. It is constant with the ambient temperature, not the temperature of the sensor itself. And we control the ambient temperature with an air conditioner, and we set our temperature to 16, 20, 25, and 30 degrees Celsius. 30 degrees Celsius was the maximum we could go up to, so we couldn't go further. And we set the camera distance to 1.6 meter. And as from the data sets of these cameras, the operating the operating temperature are 10 to 25 degrees Celsius for K4A, while 0 to 35 degrees Celsius for real sense. And as we can see in the figure, is when the temperature are within the operating range of the cameras, there are no significant noises introduced. While in case of real sense, as we exceed the temperature, uh, which is beyond its operating range, we have encountered significant noise. While in case of real sense, since its operating temperature is 0 to 35 degrees Celsius, and these temperatures are within its range, we saw no such significant noise introduced. And when selecting a depth camera for computer vision applications, it is essential to consider the warm-up time, operating temperature ranges, reflectivity of the target surface, and environmental factors like illumination and temperature. And in conclusion, we recommend using these depth cameras, considering the influence of the above studied factors in addition to the requirement of the specific experiment. And thank you.
Thank you. Okay.
Hello, Mr. Sanjay. I have only one question here. Your presentation was good. Are there specific challenges or strengths in noise reduction techniques employed by each camera? And also, I just want to know to what extent are the depth estimation results affected by different lighting conditions and other environmental factors for each camera?
Answering to your first question, ma'am, actually, these cameras have inbuilt noise reduction hardwares, and they also implement that in software. But as we go to the extreme, for example, in case of KFOA, they have implemented a noise reduction hardware for illumination, and they also compensate that with integration time. Uh, it adjusts the lighting conditions in hardware so that it can capture data dynamically depending on the outside illumination. So yeah, they have implemented both in hardware and software, but as we go to the extreme conditions, they are less effective. And answering to your next question, ma'am, uh, actually we haven't explored all the environmental conditions. For example, in case of temperature, we haven't included the humidity, the uh, the factor which can also affect the temperature, and other factors like the speed of wind from the AC, and similar other factors are also to be studied. But within the scope of our experiment, these are the conditions we have studied.
Okay, fine, Mr. Sanjay. That's it from my end.
Thank you, ma'am.
Sanjay, I have just one question.
Okay.
The one that you testing is just image, right?
Uh, sorry, sir. Can you repeat your question?
The data that you use is just image, right?
Actually, it's not just the image. It is depth image, and also we have also extracted the depth data, which are the distance values that we get from the depth images.
Um, it's supposed to be a video, right? You extract the image from the video.
Actually, we captured a small video that is
Yes.
with, yeah, 30 FPS, and within those frames we extract the distance values at each pixels.
Okay. So did you evaluate based on the features used to assess video, like the smoothness? No.
Actually, no, sir. That is not within the scope of the work, because the smoothness and those factors doesn't quite affect the depth estimation accuracy of the camera itself. It is like uh, is okay. I think we can. Uh, I think you may be mentioning to the texture object textures. Am I correct, sir?
So I'm referring to how smooth is the transition from one frame to the other frame if you change the environment.
Actually, we haven't studied that.
Okay, okay. Thank you.
Okay, thank you, sir.
So now moving on to the next presentation, I'd like to call Risti Acarado to present her paper on the titled Oralysis Development of an Expert System for Early Diagnosis of Oral Health Problems. You may please share the screen.
Okay, yeah, good day. So I'm going to share my screen now. Okay, good day again. I'm Dr. Risti Acerado. In behalf of my co-authors, I will be presenting to you our research paper with the title Oralysis, Development of an Expert System for Early Diagnosis of Oral Health Problems. So, in the Philippines, a substantial proportion of the population confronts challenges, resulting in consequential health implications. Some predominant issues in oral health manifest as dental caries, denoting the occurrence of tooth decay and periodontal disease, including the onset of gum disease. According to the Department of Health survey stating at the age of 5, caries prevalence is 87.78%, while 48% exhibit manifestations of periodontal disease. Not many Filipinos have no access to oral health care due to location or social status. And healthcare is not a priority, causing an increased number of oral cancers and health problems in the Philippines. Government underscores the paramount importance of prioritizing dental health care within their constituencies without realizing that dental problems could lead to more physical and mental problems. As they study on a smartphone-based decision support tool for the early detection of oral potentially malignant disorders, the authors pointed out that the most of the patients with oral cancer were diagnosed at a late stage, wherein managing the disease could already be late. A slogan here shows that it is expensive to get sick in the Philippines. Medical needs of the people in the rural areas only get attention usually when there are medical missions that's happening once every few years. However, many areas never gets any visits of medical missions or health programs of the government. Now, even those who have access to medical facilities and government health centers, still many Filipinos look for answers from the internet, aiming for good oral health, but looking for cheaper and accessible alternatives to learn more about oral health care and oral related cancers. The graph here shows that there was a rise in searches in Google Trends related to oral cancer based from the study published in April 2023. Another study also determined that the results revealed that interest in oral cancer Google searches were significantly higher in 2019 compared to 2009. Thus, this research results of Google search trend signifies that technological innovations such as internet, web, and mobile applications could be utilized in healthcare services and could help address dental health challenges. Now, of course, therefore, in response to the escalated prevalence of oral diseases and with the limitations of current solutions to prevent the growing number of oral diseases in the country, the research aimed to develop a mobile-based expert system named Oralysis. This research aimed to develop a mobile-based expert system named Oralysis using the decision tree algorithm. Moreover, this paper also aimed to evaluate the application's performance, focusing on functionality, usability, and efficiency, adhering to the ISO 9126 quality standards. So the Oralysis mobile application sought to scrutinize symptoms and generate dental diagnostic reports that could support dental experts in their decision making. Listed here in the scope of this is the scope of this study. It can diagnose different, the application, the Oralysis application can diagnose different common oral health diseases. It can also provide information on different oral health problems under the category of lips, gums, cheeks, and tongue. And it includes descriptions and pictures of the symptoms physical manifestation of the oral health diseases and provides basic remedies for prevention and awareness. The figure here shows the system framework of the oral disease mobile application. There are three tiers: the presentation, logic, and data. The users engage with the application within the presentation tier to facilitate diagnostic responses and learn more about oral care. This interaction is then directed to the logic tier, encompassing both the accumulated data and the processes integral to the decision tree algorithm. The data tier represents the database repository for information storage and retrieval.
Ma'am, just
The,
a reminder, 10 minutes are over. You'll have to wrap up.
okay, so in this research, we use the RAD methodology as it can, we follow this to quickly develop the minimum viable product and of course, focusing on the implementation of the decision tree algorithm. So this is the a snippet from the coding of the decision tree algorithm, which was employed in the construction of an interactive diagnostic tool wherein a sequence of inquiries is presented to the user based on their reported symptoms and responses. The algorithm initiates the diagnostic process by presenting, of course, the four distinct like the regions, lips, cheeks, gums, and teeth, and tongue. Here are the profile of the survey of respondents. We have here the professionals, the he oral healthcare professionals that are knowledgeable in the diseases, the normal users, and of course, the people that are experiencing oral problems. And the summary of evaluation shows that all criterion got a higher rating, which the outcome shielded a rating of 4.06 of 5-point Likert scale, indicating as highly acceptable. So here are just some of the sample screenshots of the application. And in conclusion, Oralysis stands as a proficient mobile application designed for disease diagnosis through a structured set of inquiries. Upon completion of the diagnostic process, the application furnishes results containing comprehensive information about the identified disease, and the implementation leverages, of course, with the use of decision tree algorithm, organizing symptoms with discernible physical manifestations. And of course, another one with as one of our objectives is to evaluate the application using ISO. Based on the result, it validates the attainment of the project's objective. The application course could surely help individuals who want to know more about oral diseases. They can initially find answers to the symptoms they are experiencing, of course, know the gravity of the disease, and pursue dental care from the experts. And diagnosing oral disease early could help dental experts effectively cure, manage, and be well guided in further examining the patient. And for the recommendations for future works, for future researchers, to augment the mobile application's functionality, it is recommended to broaden the compatibility of the application to various platforms. And also, it is an advisable course of action to also include enhancing the application's diagnostic capabilities to encompass a broader range of oral problems, of course, aiming to optimize the efficacy of the diverse oral health concerns. So that's it. Thank you so much.
Yeah, thank you for your presentation. I'm just curious. How do you validate the accuracy of the proposed system?
Actually, we with the data set that we have, and after testing the applications, we validated that with the expert.
No, I mean
Also,
the expert system. When you ask for something, they will tell you the answer, right?
yeah.
So how do you do the testing and then validate the percentage of accuracy?
So when we have tested the application, initially we have validated also from the oral care experts, and aside from that, we also had tested compared with the data set that we had.
But the expert system is based on rule, right? Rules.
Yes, the if else. Yep. Yes.
Yeah, if else and so on. But how do you check if there is some missing missing condition which is not met by the expert system? So what tests you do and so on. So I think that is more critical in terms of validating the expert system. But the one that you mentioned in this paper is more on the user acceptance, right?
Yes.
Yeah. Okay. I think that's all. I just suggest that you look at the accuracy and the rules covered, because that is the bread and butter of the expert system. Okay.
Noted. Thank you.
So let's move to the next presentation. I'd like to call Mr. Enrique V. Carrera for the paper titled Tracking and Analysis of Flight Missions Using a Low-Cost Infrastructure. So you can present now.
Would you let me to share the screen, please? Could you see my screen?
Yes, sir, it's visible.
Thank you. Hello, everyone. It's my pleasure to present to you this morning this work entitled Tracking and Analysis of Flight Missions using a low-cost infrastructure. My name is Enrique Carrera, and this work has been developed in the Department of Electrical Engineering at the Ecuadorian Armed Forces University. This is a brief outline of my presentation, but due to the limited time we have for this talk, I will simply go on to discuss the work developed by us. During pilot training, systematic post-flight briefings play a critical role in the learning process. In order to carry out these post-flying briefings, it's necessary to have real and validated information about the entire route followed by the aircraft. Although most modern airplanes and the state-of-the-art drones already have all the necessary devices and tools to support post-flight briefings, these systems are based on proprietary hardware and software, restricting the flexibility and use and increasing the overall costs. However, there are still large fleets of all-light planes that do not incorporate this type of technology and are used for training purposes. Therefore, this work proposes the design and implementation of all the hardware and software necessary for the tracking and analysis of flight missions carried out by small airplanes or drones. The proposed implementation includes a small off-the-shelf electronic device that records the raw GPS coordinates of the route taken by the aircraft. Those raw coordinates are entered into a computer program that allows for the visualization and analysis of various flight parameters such as position, velocity, and acceleration. However, GPS readings available on commercial GPS devices include some random errors that lead to inaccuracies, especially when considering relatively high speeds. So in order to improve the accuracy of the visualization and analysis tool, the extended Kalman filter is used to generate smoother paths. Similarly, regression algorithms based on machine learning are also evaluated to correct those noisy readings in the raw GPS coordinates. Unmanned aerial vehicles or drones were used to evaluate the implemented prototype in addition to some other tests with ground vehicles. As we already mentioned, the accuracy of the GPS receivers can be affected by several factors, such as signal blockage, weather conditions, satellite geometry, and errors in the GPS receiver itself. In particular, it is possible to determine a measure of the geometric quality of the satellite configuration from the point of view of the GPS receiver, called dilution of precision. Especially, the horizontal dilution of precision and vertical dilution of precision indicate the degree which satellite geometry affects GPS accuracy. In addition, vertical dilution of precision has been shown to be normally higher than the horizontal dilution of precision. Several techniques have been proposed to mitigate these inaccuracies of GPS readings and improve the reported precision, but we are just interested in low-cost alternatives. An important part of our processing algorithms is the Kalman filter. This is a mathematical algorithm used for state estimation in dynamic systems. This filter provides an optimal solution to estimate the actual state of a system by combining real measurements with predictions from the model. Extended Kalman filter is just an extension of the basic algorithm to handle nonlinear system models. On the other hand, machine learning regression is a statistical modeling technique used to predict continuous numerical values according to input features. Machine learning regression finds the best fitting function that minimizes the difference between predicting and actual values, enabling accurate predictions and innate understanding of the relationships between variables. Therefore, the system was designed to comply with the requirements gathering process carried out during the flight briefings. Basically, the readings of the GPS coordinates require two input parameters, the sampling frequency and the minimum number of connected satellites, while the coordinates saved in the device are associated with a manually configurable route ID. After copying the file of geographic coordinates to the computer, the data is filtered using the extended Kalman filter or machine learning regression. Finally, a tracking and analysis tool was developed in MATLAB, allowing to load and filter the routes described in the CVS files. The implemented hardware includes a ESP32 microcontroller, a Neo 6M GPS module, a micro SD card module, a monochrome OLED display, and two rechargeable lithium-ion batteries. This figure shows the graphical interface of the tracking and analysis tool. This tool is capable of visualizing up to 5 different rows simultaneously. The visualization of the roads can be done in a predetermined mode with respect to a fixed reference point or in a satellite mode. In this example that we have here, the interface includes a view in satellite mode. In order to evaluate the performance of the implemented prototype in terms of the accuracy reported by the different filter techniques, two types of roads were used. The first one corresponds to the device mounted on the dashboard of a car traveling on ground roads with significant altitude variation. And the second one corresponds to the device mounted on a matrix drone, which has a flight autonomy of 40 minutes and a weight of 3.5 kilograms. The main advantage of using ground roads is that we have access to the exact geographic coordinates of the ground path, and we can compare the GPS readings with the actual road traveled by the device. This figure shows an example of a ground road that was tracked by the device mounted on the dashboard of a car. In this case, as we said, we have access to the exact geographic coordinates of the road traveled by the car, including latitude, longitude, and altitude. Once the road is recorded, the coordinates are loaded into the tracking analysis tool to determine the accuracy performed according to the different filtering and visualization options. Now this figure is a visualization of the roads shown in the previous slide, but in the default mode of the tool and using a fixed reference point. In fact, in this figure, three different paths are superimposed. First, in red, are the coordinates corresponding to the real road. In blue is the route established by the raw measurements taken by the GPS device, which is quite noisy, as we can see, and with abrupt changes. And third, in green is the road estimated by the extended Kalman filter, which has smoother variations. Similar plots are also obtained for the other ground roads evaluated in this work. On the other hand, this figure shows an example of an aerial road taken by the matrix drone. Here, the road generated by the raw GPS coordinates is plotted in red, and the road filtered by the extended canal filter is plotted in green. Based on these trajectories, the root mean square error of the measured and processed roads with respect to the real roads was determined. This slide shows two tables. The top one corresponds to the ground roads and the bottom one to the aerial roads. Each table shows the average errors for the three axes analyzed in this work using the raw GPS coordinates, the extended Kalman filter estimation, EKF, and the regression based on the exponential Gaussian processes, EGP. This one is the best machine learning regression algorithm that we have. It can be seen in the ground roads, the top table, that the extended Kalman filter reduces the error with respect to the raw GPS measurements, in addition to keeping the trajectories much smoother. Exponential Gaussian processes, on the other hand, failed to improve the results already obtained with the extended Kalman filter. In the aerial roads, the bottom table, we see again that the extended
So
Kalman
your
filter
10
presents.
minutes are over. Just a gentle reminder, you'll have to wrap up.
Okay, thank you. We see that extended Kalman filter presents better results in terms of a lower error. In fact, the error reported in these aerial roads is lower than the error shown above for the ground roads. As our main conclusions, we can say that a low-budget system was developed to store and visualize the roads defined by smaller aircrafts and drones. It has been demonstrated that the system is capable of tracking the routes followed by the device with a high level of reliability and precision, approximately 3.5 meters in the horizontal plane and 6.5 meters in the vertical position. The application of the extended canal filter and machine learning regression has allowed to filter the data generated by low cost off-the-shelf GPS devices. Finally, the developed system obtained relatively accurate readings, constituting a first step to obtain certified and reliable schemes for tracking and analyzing training flights at a very low cost. As future works, we can mention that due to the budgetary limitations that the project has had, it will be important in the near future to evaluate the position and device using more precise equipment. The device must also be evaluated inside the manual light aircrafts, where the velocity and positional ranges are much wider. And finally, these tests will also allow us to know the attenuation conditions of the fuselage of our real aircraft and find the operating characteristics of the device to use external antennas with a higher gain. That's all that I have prepared. Thank you again for attending this presentation.
Mr. Hendrik, I have a very general question. How seamlessly does the low-cost tracking infrastructure integrate with existing aviation systems and protocols?
Well, the idea that we have is to use this small prototype in small airplanes where the fuselage is not a problem to install this type of devices. And the idea is to use this device in offline recordings in a way that we can do these post-flight briefings during the test in the training of pilots.
One more question I have. Are there any limitations in terms of geographical ranges or the number of concurrent flights that the low-cost infrastructure can handle?
Could you repeat the question, please?
Hello?
Could you repeat the question, please?
Okay, okay. Are there limitations in terms of geographical range or the number of concurrent flights that the low-cost infrastructure can handle? You have implemented some model.
Actually, there is no limitation in the range of coordinates that we can have. The tool is allowed to load several paths. The visualization of these tracks is limited to 5 simultaneously routes, but this is because if we use more than 5 routes, the graphical interface is very loaded.
Okay, fine, Hendrik. Fine.
Okay, I have one question only.
Sure.
Oh, this is regression problem, right?
Yeah,
So
this is
time
a
series.
regression problem.
Yeah. I saw that you mentioned X, Y, Z error. Why didn't you measure the mean square error?
Well, because it's a regression problem and we have the coordinates in three axes, we use X, Y, and Z to represent the latitude, longitude, and altitude of the plane. And the mean square error we are using in order to estimate the difference between the real position and the predicted by the model.
Is that value is mean square error, MSE?
The root mean square error, RMES, the root mean square error.
RMSE.
Yeah.
Okay. Okay. Good work.
Thank you very much.
I sincerely thank our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on the behalf of the whole team, thank you for the support during the ninth version and all the previous 8 versions of the conference. We will be happy to have you on the 10th conference in 2025 as well. All the presenters would be getting their digital certificate through email within the next 2 working days. Further, all the papers have already been forwarded to the Springer. The publication will be live within 6 months. Kindly cooperate with the team of ICICT 2024. I would thank our session chair, Ms. Ratna Patil. I would also like to thank Professor Rainer Alfred for chairing this session. A token of appreciation to the chair on behalf of Team ICICT 2024 and Global Knowledge Research Foundation and partners. Thank you for your valuable presence. So now I kindly request you all to switch on the camera for a quick snapshot of the virtual conference. So guys, please. Can everyone please switch on their cameras? Okay. Uh, the rest of the people, if it is possible, please could you switch on your cameras? I'll take the snapshots. Fine, I'll take one. We can now end the meeting. Thank you all and have a good day.